where we left off yesterday in the previous session. So yesterday, if you remember, we've started talking about, just give me a second. I don't think the YouTube stream is working. Just a second. Let me just check with the team on the YouTube bit. Because that's where the recording will be. So let me just check with the team once. As soon as the YouTube live will also begin, we'll start with the discussion. Otherwise, this will not be a part of the recording. So that can create an issue. Just give me a minute. That's where the recording will. Okay, perfect. Yes, so now that is working. So yes, now we can get started with the session. So yes, like we were discussing yesterday, we started our discussion on Python, if you remember, and we've been talking about some of the features of Python, some fundamentals of Python. So we have talked about different things like printing basic, hello world statements. We have talked about data types and variables. We have talked about um, conditional statements. We have talked about list, set, tuple, dictionaries, which are different ways of working with data, in Python. And now we are going to continue that discussion and move to more advanced concepts. So in today's session, we are primarily focusing on functions and classes. So we'll start off with functions. We've already discussed it in brief, but we'll discuss another round on functions. There are some special functions that I also want to discuss. And then we'll take our discussion to the concept of object-oriented programming, which is a very important programming concept. And there's a story that I will tell you today about how programming has evolved over the years. And we have gone from what is called, sequential programming to object-oriented programming. So there's a discussion on that, which I will tell you. I'll walk you through it. So it's like, taking a look at the history of several years of programming. So we'll do that. But after we finish our discussion on functions. So first up, what we're going to do is we are going to start off by discussing functions in detail. So I'll just, share my screen again. And as always, we'll move to our compiler that we have been using, and we'll talk about functions a little more. So yesterday we have been talking about functions. We've started our discussion, but let me quickly recap what a function is, and then I'll talk to you about that in more detail. So a function in Python is basically a named block of code, right? That's how we define it. And it's basically just that. We have a couple of lines of code, we give it a name, and then we can call it whenever we want. But in addition to just being that, a function can also accept certain parameters, and it can also respond with something, right? So in addition to just, giving name to a couple of lines of code, we can also accept inputs, and we can also return results from the function. So that's effectively what a function is. It's very simple to define. So we have the, just type a comment out, functions. So just like yesterday, I'll give you all the code in one file, like I did. So we have the define keyword, that's def, followed by the function name. Let's say we have a very simple function called add, and this function for now does not take any parameters, and it looks like this, right? Then what we can do is we can write the logic here. So let us say that we want to put, let's say 5 plus 10. Okay, now of course this is static data. There is nothing dynamic in it, which is to say that the user is not giving any result. Okay, and instead of printing it directly, what we can do is we can return the result. So this function will add the two numbers and return the sum, which is 15. Right? So the function will return 15 to us, and that's effectively what we are looking at. Then, so this is what we call the function definition, because over here, what we are doing is we are defining the function. Okay. Then at the end, or when the function has been defined, we need to invoke it or call it. So we call that function invocation or a function call. So that is simply again the same function name followed by curly brackets. So this is going to be calling the function, and this will keep the value 15. So when the function is called, a value is going to be returned. So then what we have to do is in our logic, we have to somehow store that value or we can print it out. So if I directly go for a print, you can see we get 15, which gets printed out in the console. What we can also do with the value is we can say result is equal to, and then I can call the function and then print result. So this way also we are storing the value in a variable and we can work with it later. Let's say you want to, it's a tax calculation or it's some bill calculation. You want to add some taxes to it, etc., etc. So you can do all of that to the result and then finally display the total amount or something like that. So again, this is the simplest format for a function. Now, what we can do, of course, is we can also pass some data. So this function doesn't make any sense, right? We want to make it more interactive, more dynamic. We would want to maybe, let's say, pass in two numbers that the user can provide, and then that should be used for the calculation. So this is known as parameters in a function or arguments in a function, right? So the term is argument or parameter. So again, when we define the function, we call it, parameter or argument. So this can be, for example, say num1 comma num2. Now, if we don't define any data type, just like JavaScript, this is going to be a dynamic type, which means it will accept all kind of values. And then we can say num1 plus num2. Okay? And then the rest of it will still be the same. But then over here, we have to pass in the number. So let's say we pass in 10 comma 5. Now we can run this and we will still get 15. If we pass different numbers, we get a different output. So this function is much more reusable now because of the fact that we can pass in some data to it, and according to the data, it will then work. Now, since this is dynamic typing, which is to say that we have not really specified any data type, we can also pass in some other data types. For example, let's say we are passing a string here. So this will then still, give us an error. And that is because it is saying that you cannot combine integers and strings, right? So Python is smart enough to figure out that integer and string cannot be added. However, if we pass in, let's say hi and hello, then this will ideally work. You can see this gives us concatenation, right? So as long as Python does not get confused in the data type, it will be fine. So it cannot add a number with a text. It knows that, and it will throw an appropriate error. And sure, we can pass in decimal data or floating point data. That will work fine. 110.67. So we'll talk about one more concept called type conversion a little later. I'll tell you more about how things work in terms of data types in Python. But yes, we can definitely pass in negative numbers also. We can pass in 10 and minus 5, and this will give us 5, right? So 10 plus minus 5 is 10 minus 5, which gives us 5. So all of the mathematical stuff will work fine. My point is, even if we pass string data, it will still work fine. Okay, so strings can also be added to each other. It's called concatenation. And you can see there are no errors that we get. So that's how this bit works, right? Now, the next thing that we have to understand regarding functions is that technically it is possible to return multiple values from it. For example, we can return, let us say we return num1 plus num2, and we also return num1 minus num2. Okay, if you try to do this, okay, then what will happen is it will say unsupported type. So this is not a string. Let's pass in numbers here. And now you can see it gives us a tuple. Okay. So this is something that a lot of people get confused with in Python because most other programming languages do not support this, right? So almost all other languages, including Java, JavaScript, C++, no other language supports this kind of a declaration. Okay, or this kind of a return where we can actually return multiple values in a function. In the case of Python, we can return them and they are returned as a tuple. So if you see here, we say we get two values in a round bracket, right? Or parentheses, which is basically a tuple. Can you quickly tell me in the chat which bracket indicates a list in Python? Which brackets indicate a list? Square brackets, perfect. And now which brackets indicate a set in Python? Which brackets are for a set? curly brackets, flower brackets, whatever you call them. But yes, curly brackets or flower brackets indicate it is a set. List is square brackets and tuple are round brackets or parentheses. And then if you have a key value pair in curly brackets, that makes a dictionary. And we have already discussed this in the last session. So this is a little more about functions, right? So this is a standard function in Python, which means we can perform whatever logic we want. And then finally, we can return the value and we can work with the return value and get something done. Now, this is not the only way to make functions, however, right? So Python also supports a couple of different concepts. One of them includes creating anonymous functions, which in Python's terms are called Lambda functions. Okay, so there's a special term called LAMBDA, Lambda functions. And these are special functions in the sense that they are single line and they return a single value. Right? So they are not multiple lines, which means they can only contain one line of code. Okay. So let us say that we want to write the same project, add function again. What we can do is we can say add is equal to lambda. Okay. And then we can expect parameters. So x comma y, num1 comma num2, whatever works with us. And then we have to just specify the return type. So return value. So like num1 plus num2. That's it. And then we can have the same code print add 15 comma 9, for example, and this will go ahead and get it done for us. You can see we get 24. So this is more variable style assignation, assigning a value. If you see, add is a variable here, and this is the function. So again, it's a special syntax. It's called a lambda function, which is basically an inline function or a single function, right? Now we can try to return multiple values from it as well. And you can see that this will not work, right? This gives us an error, and that is because this is not supported. So Lambda functions in most common cases, work with single return. So they can take as many inputs as needed, and they simply return one, like whatever logic we write in one line. That's the only logic that it can return. So in a lot of places where we want to say directly print something, then we don't really want, we don't like in places where we don't want to give it a name or we know that there's only a single line of code, we can go for these kind of lambda functions. So this is sort of a shorthand, you can say, in functions or for functions in Python. It's a very, shorthand setup, which means we are trying to compress the function. So we don't have to write define and then colon and then return. All of those keywords are skipped. And we only have one keyword, which is lambda. Okay. So this is how lambda functions can be defined or created in Python. Now, in addition to this, what Python also gives us are three really, really, really important functions which work with data. Okay, there are three very important functions that work with data. So we have the map function. I'll show them to you one by one with examples. We have the map function, we have the filter function, and we have the reduce function. Okay, so very, very, very important, these three functions. Okay, let's take a look at them one by one. Now, map, as the name suggests, is basically a function which is going to go through every single value, say in a list or a tuple or a set or a dictionary. Either way, mostly we use them for lists, but it can be any structure, and it will go through all unique values or all values one by one, and we can make it perform some task. For example, let us say that we have kind of data. We have numbers is equal to 2, 3, 4, 5. Now, let us say that there has been some miscalculation by somebody, and we have to add a particular value to both. Or let us say that this is the bill amount for several different bills, and we want to now add the tax to all of these bills. So let us assume that we have 1 rupee tax. Just to keep it simple for us, let us assume that we have 1 rupee tax, which needs to be added to all of these bills. So what we can do is we can create another variable, let us say with tax, and then we can write a logic like this. So we can say list lambda, list map, and then we can write lambda x, and for each value x plus 1, okay, and then return the or perform it on numbers. So map takes two parameters, right? Map takes two parameters. Let me break it down for you one by one. First, what we are doing is we are adding the lambda logic. So we are saying lambda for each value, change it by one. Okay, so this is a tax calculation, tax addition 1 rupee. So we want to do this for every item in this list. So for this, we have to call the map function, map lambda so and so on the numbers list. Okay, so if I now print this out with tax, then let us see what we get. So you can see this is an object. Okay, we don't get the actual list. So this is performing the calculation for us, but it is not storing it as a list. So then what we do is we go ahead and explicitly convert it to a list. So now if I go ahead and run this, then you can see we get 3, 4, 5, and 6. This is going to be our list. Okay, so that's the setup. Okay, so this is how it works with map. So what map will do is it will go through every single item or every single element in the given list. Okay. And then it is going to perform whatever task we tell it to. In this case, we are using Lambda because we don't want to name it. So we just want to keep a simple anonymous inline function, but we can also create a more complicated function and we can call that over here. That will also work fine. Okay. That's up to us how we want to go about it. But map will basically take one value at a time or one element at a time, and it will perform whatever logic we want on all of these items one by one. So at the end of the day, we get the updated list 3, 4, 5, 6. Now, just like this, you can try different things out. So this is just an example for you so that you get or you can experiment with these things on your own. So now we are using tuple instead of a list, and you can see it works fine. We can also have a set and it will also work fine, right? The properties will naturally follow, like tuple will not be editable, set will not contain duplicate values. All those properties would still be true, but we can call it on anything. We can convert the result to anything. It need not just be or only be a list. Like anything will work. So that's our map function. Then after this, we have something called the filter function. And again, like the name suggests, filter is going to help us filter out a given value, right? So let us say that we have numbers. Let us say that we have 2, 3, 4, 5, 6, 7, 8, 9, 10, and we want to filter out all the even values from it. Okay, let us say that we want to filter out all the even values from it. So for this, we can create another variable. Let us say evens, and we can say filter. Okay. And then again, we can write a lambda logic to check if it is even. So we can say lambda x such that x modulo 2 equal to 0 and apply this on number. So it's the same logic as before. And this will, hopefully give us print evens. We have not printed it. So if you print it out, we should get only even numbers, as you can see, extracted from our input data. So this contains even and odd numbers. But when we write our filter logic, so again, what filter will do is only when a given condition is true. Okay, only when a given condition is true, it will store the result or put the element in this list. So it will start with 2. 2 modulo 2 equal to 0 will be true. So it will add it to evens. Then it will go to 3. 3 modulo 2 will become false because there is a remainder. So it is not 0, it is 1, right? And hence the value 3 will not be added to the result. Then 4 modulo 2 will become 0 again. So it will be added to the result and so on and so on and so on. And that is how the setup is. Okay. So this is our filter. There are very clear-cut use cases. If you notice it carefully, map is going to be used when we want to perform some addition or some calculation to every value in a list. Okay. When we want to change something or perform some functionality to every value in the list, that is where we will use map. Okay. And then on the other hand, if we want to filter some data out, let us say there are 100 results, out of that you want to narrow it down to 10 or 15 values based on certain conditions, we can use filter. So, for example, in a normal setup, what we can have is you can take a typical e-commerce setup or something like that, right? So in an e-commerce setup, users filter data. They will filter in price range. They might filter by brand names or company names. right? They might filter by delivery date, they might filter by ratings and etc. etc. So again, all of that filtration can work in this setup. Now, of course, we can write a more complicated logic for filter, but in this case, we are simply using a lambda function, but we can come up with a complicated logic for it as well. So this is map and filter. The next thing that we have is reduce, right? So let me quickly show you that as well. So reduce is, like the name suggests, it is going to take a bunch of values and reduce it down to a individual value. So again, let us assume that we have added 5 products to the cart and we want to sum it to the cart total. We want to add all the sums to a cart total. Okay, so that's the kind of thing that we can do with reduce. So let me give you a quick example of that as well. And then I'll give you an exercise so that you can practice these things. So let's go for reduce. Okay. Now reduce is going to be, again, let us say that we have numbers like this. So this is my numbers again. And let's say that we want to sum this. So assuming that these are product prices that have been added to the cart, we want to go ahead and we want to sum it. So we can say cart total is equal to, and we can say reduce. So this is the function. Now, if reduce does not work directly, then we can use an import. So there's an import which is from function tool, import reduce. Okay, this is import if it is not working directly. Okay, then we can again write some reduce logic. So let's say lambda x, and then we can say, so reduce takes 2 parameters, right? And then we can say x plus y. So this is going to add the previous value. So basically 2 plus 3, 5, and then 5 plus 4, 9, and then 9 plus 5, 13, and so on and so on. That's how this is going to work. And on which list? On numbers. Now reduce, this will not be converted to a list, unlike the other two, right, where we have converted them to a list. Why? Because it's not a list. It's going to be a single value, the total sum that we get at the end of the day. And then, of course, we can print the cart total. So if we try to do it this way, let me run this. You can see now we get 54, which I am sure if you add it manually, it will be the same thing. Right? And we can perform whatever logic we want. If you want to subtract it, you can go for subtraction. It'll be like 2 minus 3 minus 4 minus 5 minus 6, etc. There can be multiplication. So it will multiply all the values, right? Etc. etc. So again, that is how reduce will work. We can also write the logic here. Let us say that there are a number of units for each product. We also have quantity. So then we can say, for example, take the previous price plus n times y, something like this. So this will be like take the previous product price plus n times quantity. But of course, we don't have that n here, but I'm just giving you an example. So we can customize it the way we want it to work. Of course, that is up to us. So these are 3 very, very important functions: map, filter, and reduce. Okay. Now I'm going to give you 2 minutes. I'll keep the code on the screen. Okay. I just want you to go through it. Just read the code. Just understand what these functions do. Okay, just go through it. I've also kept the output next to it. And then there is a challenge coming up for you on these 3 functions. Okay. So I'll give you a task to create something based on these 3 functions, right? So I'll give you just 2 minutes. Just go through it, and then I'll give you the task. So the cart total is going to store the result of reduce. Reduce is going to reduce it down to a single value. That's why it's called reduce. So it's reducing this list down to a single value. So we are storing it in cart total, and then we are printing it out. Just like we are storing the results here, in the same way, we are storing the result of reduce in cart total. So map and filter are going to give us lists, right, or other objects which can be converted to list or tuple or set, whatever we want. Reduce, on the other hand, is different, right? So what reduce does is, reduce is going to reduce the value to a single number. Okay. So we have some 10 values here, assuming that we have 9 values here. What we are doing with reduce is we are telling it, take the first value and sum it with the second value. Okay. Take the first value and sum it with the second value. So this is called aggregator. In technical terms, it's called an aggregation. So what will happen is, first 2 plus 3 will work. This will give us 5. Then 5 will be taken as the next input, and the next number 4 will be added to it. So 5 plus 4 will become 9, right? Then what will happen is 9 will be taken, and then 5 will be added to it. So 9 plus 5, this will become 13. Then 13 will be taken and the next value 6. We added to it, this will become 19 and so on and so on and so on till it reaches the end. Okay. Now, how it takes like that, that is not for us to worry. Okay. It basically automatically takes it. It is built into Python. You can check the definition out if you want. You can just Google it, Python reduce logic, and it will give you the exact code, how it is working. Okay. Reduce in mathematics sure means decrease, but in this context, reduce means reduce the list to a single value. Okay. It means that even if the list contains 1,000 items, we are reducing it to a single result. That's what reduce does. And the final question that I have is that I have in the chat is regarding this list part. So the reason why we are using list with map and filter is because we are getting multiple values, right? Map is working on every item in the list. Filter is working on selected items in the list. So it still needs to store more than one value, which is why we are making it into a list. But reduce is going to take the entire list and narrow it down to a single value. This is not going to return as a list or a set or a tuple. It's going to return as a single number, which is why we are not using list here. It does not make sense to convert this to a list. Why? Because the list is not being returned. You can see it says an integer, a single variable is returning. How can you store it in a list? It's not a multiple, like it's not a few different values. It's a single integer. Okay. So that is why we don't use list over here. All right. Perfect. So I'll give you 2 minutes. Just go through this code carefully because you have to now work with it. And I'll pull up the challenge on the screen in 2 minutes. Okay, so I'll just give you 2 minutes. Just read this code, understand what is going on. Let me know if there are any doubts or questions. And then I'll give you a challenge on these three. Okay, so here is the question for you, right? So the question is on the screen. I am providing the data to you in the chat. Okay, so I'm going to give you the data in the chat. You can copy it from there. Let me know if you're able to copy it. Okay, you should be able to copy it. If not, I'll give it to you as a file as well. So if you're not able to copy it from the chat, let me just make a new file and I'll just attach it as a file itself. Okay, chat. What is our chat? So I'm sending the data to you as a file. It's called data.py or data.py, and I've sent it in the chat as a file. So that's the dummy data or the sample data that you can work with. Okay. The questions are very self-explanatory. I don't think I need to explain it to you. This is sales data. So the first thing is you have to use map to basically calculate total sales for each item. It's not a total sale for the entire thing. So based on the values in the dictionary that I have given to you as sample data, you have to try to calculate total sales per item. That's one. The second thing that you have is you have to filter high sales items. So wherever the sales are greater than 1,000, which you will calculate, right? So per product, wherever the sales are more than 1,000, you have to filter that and finally calculate the total revenue. So we have to use reduce to calculate the total revenue. It's going to be very simple. It's exactly the same thing that we have just done. I mean, you don't have to come up with a lot of custom logic. It's just that instead of a simple list, you have a dictionary to work with. That's the only difference between the two. Okay. And I'm going to put up a timer on the screen as well so that we have some sort of a restriction as when to, so that we know when to finish it. So the timer is also on the screen now. And let me just move it. Okay, this looks good. So I'm keeping the timer on the screen along with the uh, question and the data is in the chat. Okay. Now it's very important that you try this out. Okay. It's very important you try this out. I've sent the data twice. I've pasted the data as text also, and I have uploaded the data as a file in the chat as well. So please scroll a little and try to, okay, let me just, disable the chat for a minute. Okay, done. So I've disabled the chat. So only my chat will be visible for now. So try to work with this data. I've given it to you in the chat. It's very important that you try this out. And once we come back in 5 minutes, I'll then show you the solution, of course, and then we'll move to the classes and objects part. All right. So give this a try and let me know in the chat once you're done. I will enable the chat in 2 minutes. So then you can tell me when you're done. So this I'm doing for people who are on YouTube live. I can't directly send this on YouTube. So okay, I will just do this instead of all of that. Let me just put it on GitHub itself. So you can just take it directly from the repository itself. Done. I've added a file called data.py, the same file that I've uploaded. I've added it to our GitHub repository. Okay. So you can take the data from over there. If you just go to the repository in the very first page, you'll see a file at the end called data.py. This is for people on YouTube live. So you can take the data from over there. Okay. I hope you already have access to the repository. Please open it and you can take the data from there. And for people on Zoom, I have already sent it to you. So you can continue working with this. Let me just reset the timer as well. And done. So yes, you have the data, you have the question. I'll give you a few minutes, work on it. And then let's come back and continue with our discussion. So we'll first solve it and then we'll move to object-oriented programming. Okay, and we are back. So I hope everybody was able to try it out. I am enabling the chat now. So let me know if you're able to get this done. Just send a yes in the chat if you were able to. And I'm now going to go back to our compiler. I will comment out the existing code and I will paste the question in. Okay, again, this will just be there for our reference and we'll just try to solve it one by one. I'll also quickly paste the sample data that I had given you. So let me just paste that in over here. So this was the data that was provided to you. This is basically a dictionary, but a list also. So it's a list of dictionaries, right? Wherein we have multiple values that are given and they are stored in a list. Okay, so that's done. Now, the next thing is the first question is you have to calculate the total sales for each item. And let us go ahead and try to do this. So I am really impressed. A lot of you have given code in the chat, so that's good. I hope you have written it, because I mean, like, I hope you have been able to understand this properly and get it done. So that's great. Keep it up, you guys. And yes, so let's go for total sales. And this is going to be a quick setup. So this is a map function. So we know that we need a list and a map. And then what we need to do here is we have to use map to create a new list. So that's done. A list is being created, map is being used, where each dictionary contains the item name and the total sales for that item. So currently, if you see, the dictionary contains item name along with quantity and price. So we have to change it in a way that it contains the item name along with the total price. Okay, it does not contain this quantity and price individually, but it combines the two into a single field. That's our logic. Okay, so again, we can write a lambda function for it because we don't want to create a separate function or give it a different name. And then we can say X, and then we can create a dictionary. So this is the return value, right? This is the return value. So we want to return a dictionary at the end of the day. And that dictionary is going to contain the first field item, okay, which will effectively be the current dictionary's item. So we can extract it like that. We have already seen how to access dictionary items in the previous session, right? So that's done. All right, that's the setup for the first field. Then we can give a comma, okay, and then we can write the second field. Now, the second field is going to be total sales. Okay, so total sales, and this field is going to be the multiplication of these two fields. That's quantity and price per unit. Okay, so we can say X quantity times X and price per unit. So take the price and quantity from the current dictionary and multiply it. And that's it. This is going to be our setup. Now, it might look very complicated when you just take a look at it like this, but when we write it, it's actually pretty simple. So we are returning each dictionary which contains the current item name and the total sales, which is nothing but quantity times price per unit. And then where do we want to apply this function? On sales data. So this is our list on which the function must be applied. And then we can try to print it out to see the result. So print total sales. Let's run this. So perfect. This is what we wanted. Laptop 4,000, phone 5,000. You can compare. Laptop is 4 times 1,000. Phone is 10 times 500. That's 5,000. So this is exactly what we wanted. Perfect. So just put a yes or a yay in the chat if you were able to get this part done. And then we'll move to the next second one. Okay. No worries. Let me explain this to you once again, and then we'll continue. It's really important that we understand this, right? Because these three functions, map, filter, and reduce, are going to be really, really important for a daily use case. So What we want to do is we want to calculate the total sales. So I'm creating a variable for it. Then we want to convert the final result to a list. So we have written this. Then we want to use a map function to get this done. That's also given to you as a hint here. Now, the syntax of map is like this. So we can put a lambda function. This x is our input. And then this x plus 1, whatever is, this is going to be our output. Okay. And then we have to provide a comma and then provide the name of the list on which this map function must be applied. This is the normal syntax, right? Now, in our case, x is still going to be the input. So there is no change there. But x is not a normal value, but instead it is a dictionary. So now the logic in the output will change. What we want to do is we still want to keep the item, but we want to multiply quantity times price. So effectively in the output, we want it to look like this item, comma, let us say till sales. We want this data in the output. Now, how do we get the item? It is the current item. So we can say that we want to return a dictionary. So that's where we are using curly brackets. Then the first value in the dictionary must be the current item. So this is our key, just like this item. This is our key. And its value is going to be the current item value, right? So X is the current dictionary. From there, we are extracting its items value. So this is our first argument in the dictionary. If I just keep it this much and I run this, so what we will get here is we will still get a dictionary with only item names, as you can see. Okay, we only have one key value pair per dictionary, which is the item and its corresponding name. Item is the key, name of the item is its value. Now, the second argument, the second the second value that we want in the output is going to be a little more it's very simple. Effectively, we want to say total sales is equal to quantity times price per unit. That's it, right? Quantity times price per unit. This is it. This is effectively what we want to say. But we just have to put it in the right syntax. So to make it total sales, it has to be in double quotes so that it becomes the key. Okay. Then the value must be preceded by a colon. Then X quantity, we have to extract the quantity from X, and similarly X price per unit. That's it. So we want to extract the quantity and price from the current dictionary, just like we extracted the item. And that's it. When I run this now, okay, let's see, there's invalid syntax error. Oh yes, we missed a curly bracket. So we want to close the dictionary as well. And there should be a comma. And it should not be closed here, but instead there. That's it. So just a quick syntax issue. And now you can see we are back to our output. Okay. So laptop is now 4,000. Phones sales are 5,000, etc., which is perfect, which is exactly what we want. Right. So we just have to work with the syntax a little bit and we get the result. Perfect. Let's quickly move to the next one. So in this one, we have to filter it. Okay. So let us say that this is high sales filter. It's going to be the same thing. We still have a list. We still have filter. We'll still have lambda. So all of that will still be the same. And the logic, the only logic that we have to now perform is we want to check whether the total sales is greater than 1,000. That's it, right? Whether total sales is greater than 1,000. If total sales are greater, we want to filter it, otherwise not. So again, we have to extract the total sales from it, which is X and then total sales. Okay. And then we can put a condition check greater than 1,000. That's it. And then comma, where is this working? Well, this is going to work on the total sales list. That's it. And then we can print it. So print high sales filter and run. That's it. So this is done. And now you can see we only get values that are, okay, let me check once again. List is there. Then out of this, we are extracting total sales where it is greater than 1,000. And we are printing it out. Looks good to me. Oh, yes, my bad. I was looking at the previous list. So this is a previous list. I can actually comment this out. We can't comment it out. We need the calculation. We can comment out the print. But now you can see we only get those values which are more than 1,000. right? Similarly, you can create a low sales filter as well, wherein maybe the price is less than 1,000. So you can copy paste the same thing and change the condition to less than. That will give you the least sold products in that sense, right? Then let's move to our final logic, which is going to be our reduce. So in reduce, again, it's very simple. We just want to put the total sales together to get the total order value that has been sold. Very simple. So let's say we call it total revenue. Okay. If this is our name, and then this will be reduced. We don't use a list here because it's going to be a single value and not a list. So we can say reduce, and then we can say lambda, just like we did earlier, x comma y, right? And we can then say that we want to go for x plus y times or y of, so y is the dictionary value, so y total sales. That's it. This should work. And we want to apply this logic on the total sales. That's it, right? So let's go for this printing. So we can say print and provide the revenue and see what we get. Unsupported operand type. Okay, let me just rename it slightly. So let us say that we have accumulator and X. Okay. And then we are going to for accumulator plus X of total sales and then total sales. Oh, yes, you also have to provide the starting value to 0. And now you see we get 12,1280. So this is the total result. Okay. Now this is an extra argument that we have to provide, which is because we don't have a starting point. So we are saying start with 0. That's the additional argument that we are giving. And then we get the total revenue, as you can see. Right? So 12,280 is our total revenue, which we get from this. So is this clear? Does this make sense? Okay. So yes, let me quickly repeat reduce and then it should be good. So for reduce, what we're doing is this time I've just named them differently. So earlier we just called them X and Y. But in reduce, the first parameter that we pass is where the values are accumulated. So we call it accumulator. Okay. So basically, when we run through this list, what we want to do is, let me just print the list out. So when we run through this list, what we want to do is we want to add all total sales, right? So that's 4,000 plus 5,000 plus 1,500 plus 450 plus 350 and so on. And obviously we will store that result somewhere. So that is our accumulator. Okay. So we are saying store it in the accumulator and then get the total sales. So basically extract total sales from each dictionary and then accumulate it into this particular value. So that's how this is going to work, right? So again, I'll just give you two 2 minutes to just look at the code. Okay, just go through it. If there are any doubts or questions, let me know. I'll answer them and then we'll move to the next part. So just go through this code and put your questions in the chat if there are any. Okay, so let me quickly explain this to you once again. There are a lot of questions regarding reduce, which is perfectly understandable. It's a different setup, a little different. So let me walk you through it. So this value that we have here, ACC or accumulator, is basically storing the result, right? Storing the result at each step, storing the result of each step. So if we have 10 items in the list, for example, then we have to perform the addition 10 times, right? We have to perform the addition 10 times. So each of those temporary results or temporary additions are stored in this reduce or in this accumulator ACC. Okay, that's the setup. So again, when we have 4,000 plus 5,000, it will store 9,000. Then 9,000 will be added to 1,500. Then 10,500 will be added to 450. And 10,950 will be added to 350, right? So we have to store the previous sum somewhere to add the next number. That's where we have the ACC or the accumulator. Okay. If you're getting reduces not defined, I've already told you we have to import it. So from function tools, we have to import reduce. If you're getting the error, reduce is not defined, please import it using this line. I've already told this to you earlier as well. Okay. So from function tools, import reduce, you can just write this up top. So this will help you import the reduce function. It's not available directly. We have to explicitly import it in our code, right? So that's the setup. And this is how we can work with map, filter, and reduce. Okay, these are really important functions. So I hope that you have understood them properly. Now, let's come to the next part. So again, we'll not write a lot of code regarding this just yet, because everything in Django is going to be, just this. Like most of what we will discuss in Django is going to be related to classes and objects itself. So what we're going to do is I'll just give you a walkthrough of this and then we'll wrap up for today. And then in the next one, we'll start with our Django setup. Okay. So I'll give you a quick tour. It's going to take a few minutes, but I'm going to walk you through a quick historical developments of programming. It's really important to understand how we got here, right? So that's what we'll cover. So let's get started with this. There's a term called a programming paradigm. Can anybody tell me what that term means? The term is paradigm, Paradigm. I have written this in the chat also. Paradigm. So can anybody tell me what this term paradigm basically means? Paradigm. Paradigm. In plain English, I'm not asking you for a, like a technical definition, but in plain simple English, what will this term mean? Paradigm. Can anybody guess? Perfect. You guys got it. So it's structure or pattern, right? Paradigm simply refers to a structure or a pattern. Okay, that's what the term means in a simple sense. Now, obviously, in our setup or in our programming life, in the journey or the history of programming, there have been several distinctive programming styles, which we call programming paradigms. Okay. The latest paradigm in today's day and age in the industry today is object-oriented programming. We call it OOP for short, object-oriented programming. So most modern languages, like Python and Java, support this idea of object-oriented programming. I'm not sharing any screen. I am not writing any code. I've just put this slide on temporarily. I'm just walking you through the whole thing, right? So obviously today's latest paradigm that we have in the industry is object-oriented programming, OOP for short. And before we understand that, we have to take a quick look at how we have reached here, right? So if we go back to the early days, say about 50 years, 60 years or so, when programming was just getting started, we actually started with something similar to a DOS, right? So Microsoft came up with the very first version of something called the disk operating system or DOS, MS-DOS. And that basically was a terminal. All you got was a terminal. There was no desktop, lock screen, wallpaper, icons, nothing. It was just a terminal that you could get. And every functionality, every logic, whatever you wanted to do on your system, even if it was creating a new file, playing some song, whatever it was, you had to do it through the terminal, right? That is the first paradigm. We call it sequential programming. Okay, terminal console programming or sequential programming. Console programming or sequential programming, where we can only write one instruction at a time, and only after that first instruction is executed can we write the next instruction. So the terminal on our system, like command prompt on a Windows, terminal on a Mac, or the JavaScript console that I showed you in the browser in Google Chrome, all of these are console-based paradigms, or they are based on console-based setup, right? Where we can only write one line at a time. So unless or before the previous a command is done, we cannot write the next command. It's a sequential line by line interface. So that was called sequential programming or console programming. That was the first major structure to programming, right? Then a couple of years later, right? A couple of years later, when more programming languages came out and more enhancements and developments were made, we reached the second paradigm, which was called structured programming, or even like structured is also broken down into several. So conditional programming, right? That was the second major step. Now, there were a lot of things that happened in between. I'm just skipping to the most important ones, but there were a lot of advancements or a lot of things that happened in between. But skip a few years and we reach conditional programming. This is what we saw yesterday. Remember how we can make decisions using if else, where we can decide which part of the code should run and optionally which part of the code to skip. So based on a given condition, we are able to run a certain file or run a certain piece of code and not run a certain other piece or skip a certain other piece of code. So this conditional run of the code was called conditional programming, which was another major paradigm. Then a couple of years later, we reached a point called iterative programming or repetitive programming. Iterative or repetitive programming. This is what we saw today with map, filter, and reduce. These functions work on a list element by element. So the same logic is repeated multiple times. Right? This is called a loop. In programming terms, we call it a loop. So each run of that loop is called an iteration, which is why we call it iterative programming. So iterative programming is where we are repeating the same function a couple of times. Let us say you want to calculate salary for 500 employees, or you want to add 20 products, like some 20 products in the cart. You have to repeat the same addition process or repeat the same salary calculation process more than once. So that's called repetitive or iterative programming. That was the next milestone. After that, again, a couple of years after that, we reached another point where we had functional or modular programming. That was the next milestone, next paradigm. Functional programming or modular programming. This is where we were able to break a bigger program down into smaller parts, which is what we do with functions, right? Remember, we just saw this today. We can make functions which are named blocks of code, right? Functions are named blocks of code. So we can take a bigger code and break it down into smaller chunks. This enabled multiple people or multiple developers to work on a common project, because everybody could create their functions and they were all put together in the main file, right? So this enhanced the collaboration features that were available for programming, and we could collaborate with more developers in a seamless manner. So that was functional or modular programming, which enabled us to break a program down into smaller bits and pieces, smaller functions. Okay, that was functional programming. Then the next major update, again a couple of years later, was structured programming. Structured programming is where for the very first time we could group together data. It was nothing to do with functions, but it allowed us to group all relevant data together. right? So let us assume that there are so many things for a product. For example, product name, price, quantity, value. So kind of what we see in a dictionary. A dictionary is a structure because we are grouping multiple variables together. We are grouping the product name, price, quantity, unit sold, image, all of that in a single dictionary, right? So that was the next milestone, next achievement, where we had a structure. So we could combine multiple variables, multiple data items under a common name. Instead of creating 5, 6 different variables, we could put it all together in a dictionary. So list, set, tuple, dictionary, all of these are called data structures. That's where the name comes from, structured programming. So list, set, tuple, dictionary, all of these are structures, data structures, right? So they basically allow us to structure data in a better way, where we can combine multiple things together. A list can contain multiple values, a set can contain multiple values, a tuple can contain multiple values, a dictionary can contain multiple values, right? That's a structure. And then finally, after that, we reach a point where we have object-oriented programming. That was the next major upgrade to this. And object-oriented programming takes the concept of structured programming and adds functions to it. So now what we can do is we can create what are called classes, which can contain data as well as its associated functionality under a common unit. We can create data, or we can combine data along with its associated functionality into a single unit, a common unit. That is called a class. Okay. So that's the idea with object-oriented programming. Now, Python, Java, C++, PHP, all of these are object-oriented programming languages, which means that they support the idea of OOP. They support object-oriented programming. However, there are some languages like C or JavaScript which do not support OOP fully. C supports structured programming, but C does not support object-oriented programming. Similarly, JavaScript is not an object-oriented programming language. Instead, it works on a subsection of it or a subset of it called object-based programming. So I'll tell you the difference in just a minute. But basically, most modern languages are OOP languages. They support the idea of object-oriented programming. And then there are certain other languages like JavaScript is a famous example, which is not an OOP language. It is something called object-based programming, a subset, one level down from OOP. Okay, so that's the setup. Now, for a language uh, to be called one of these, for example, when is a language called a structured language? When can a language be called a conditional programming language? When can a language be called object-oriented programming language? So for a language to call that, to achieve that status that this language supports OOP, there are four major principles of OOP. We call them pillars of OOP, which are basically ideas or concepts that a language must provide solutions for. So just like a normal setup, let us say that you want to make somebody a class leader or a class representative. So that person needs to have some qualities or certain, um, markers, metrics, that if a person has this, they are eligible to be a class leader, for example. So in a similar way, for programming languages, if a given language, if any particular language supports these four pillars, that language will be eligible to be called an OOP language, or that language will be called an OOP language. So these four pillars are abstraction, encapsulation, polymorphism, and inheritance. Okay, I'll repeat them. I'll explain to you what these are, but that's the gist of it. So for any programming language to achieve that standard of being OOP language, they must satisfy all conditions for these four requirements. Okay, they must satisfy the condition for these four requirements. That's abstraction, encapsulation, polymorphism, and inheritance. So if any programming language provides features for these four things, then that language becomes an OOP language, right? Let's start with the very first feature, which is abstraction. Abstraction, in plain simple English, if we call it abstract, Abstract basically means vague, right? Incomplete or something like that. It means that it is not clear. That's what abstract means. So abstraction is basically the ability of a programming language to hide the irrelevant information or to hide the implementation details from the user. That's what abstraction is, right? Now, if I give you a real world example, let us say that you are driving a car. Okay, let us say that you're driving a car. You want to change the gear from first gear to second gear. How do we do this? We know we press the clutch. If it's a manual car, we press the clutch and we pull the gear down to the second one. If it's an automatic car, we don't even do that. It will automatically change it, right? Now, the user or the driver of the car, who is the user of the car, the user does not need to know how that internal mechanics is working. They don't need to know what happens when you press the clutch and move the gear to the second gear. That is hiding the data. All they need to know is turn the key and the car will start. They don't need to know that when they turn the key, the fuel is going from there and the spark is being triggered and all of that. The user does not need to know, right? Similarly, when the user wants to say make a payment, for instance, so all they need to know is enter your card number, you will get an OTP, enter the OTP and it's done. The user does not need to know how that actual debit from their account is happening and how a credit to the other account is happening. None of that, right? Very simple. The user does not need to know any of that. That is abstraction, hiding irrelevant information from the user. The second ability that makes a language an OOP language is called encapsulation. Encapsulation is the ability to group data and functionality together under a common unit, right? Group data and functionality under a common unit. So again, for example, if we take a real world example, it is just like a medicine capsule, right? I am sure you might have seen medicine capsules. What do they contain? A medicine capsule contains so many tiny medicines inside of a container, right? So when you open the capsule, all individual medicines will spill out. So in the exact same way, in encapsulation, what we do is we create a container that can contain data and functionality. That is encapsulation. Then we have the third thing, which is called polymorphism. Polymorphism is the ability for a particular piece of code to behave differently in different situations. For example, let us say that the user wants to make a payment. Fine. So the functionality is making a payment, but we give them so many options, right? The user can make a payment through UPI. The user can make a payment through debit card. The user can make a payment through credit card. The user can pay through some wallet like, Paytm or whatever other wallet. The user can make a bank transfer. The user can pay by cash on delivery. So there are so many different options available for the same functionality. And depending on what the user picks, the code will run accordingly. So if the user picks pay by cash, it will process it accordingly. If they say pay by card, it will process it accordingly. So this ability of the same piece of code to behave differently in different situations is called polymorphism. Another common example is login. We give the user so many options. Sign up with email, email password, mobile number, OTP, sign in with Google, GitHub, X, Facebook, this, that. There are so many options to create an account, right? Again, depending on what the user will choose, the rest of the functionality will adjust accordingly. So this behavior where the same functionality, making a payment, logging in, behave differently based on different situations, based on different inputs, that is polymorphism. Okay. And then the final thing that we have is inheritance. Inheritance is the ability for one piece of code to derive some functionality or capability from another piece of code. So again, this is biologically what we do as well, right? We inherit some properties of our parents, some properties from our grandparents, etc. For example, maybe our eyes look like somebody's eyes, our nose looks like somebody's nose, etc. So in a similar way, in programming also, it is possible that we can reuse existing parts of code when we are creating a new functionality. We don't have to create everything from scratch all over again, right? We don't have to create things from scratch always. So this ability to inherit or reuse existing pieces of code, this is called inheritance. Okay, so these are four important pillars of object-oriented programming. So again, abstraction is the ability of hiding irrelevant details or hiding implementation details from the user. Encapsulation is the ability of grouping data and its associated functionality under a common unit. Polymorphism is the ability for the same piece of code to behave differently in different situations, like accepting payments in various forms, different forms of login, etc. And inheritance is the ability for one piece of code to reuse or inherit from another piece of code. That is inheritance. So these are four pillars. And if a programming language provides features to support all these four ideas, then that language qualifies to be an OOP language. We've already seen some of this in Python, and we will continue to discuss more later on. So Python qualifies as an OOP language, and it provides features for all of these ideas. We can implement all of these things: abstraction, encapsulation, polymorphism, inheritance in Python. Okay. So again, I will give you more examples on this in the next session, where we'll take code snippets and we'll also discuss this in more detail. But Python is an OOP language, right? Another final thing that you should keep in mind is that these programming paradigms don't replace each other. For example, if a language is an OOP language, that does not mean it cannot be conditional. It cannot support conditional programming, or it cannot support structured programming. In fact, these paradigms build up on each other. So even today, when we run a Python script, we can still print in the console, which is all the way back to the very first paradigm, console programming. We can still make decisions with if-else, which is conditional programming. We can still repeat instructions with loops. That's iterative programming. We still have list set tuple dictionary. That's structured programming. So all of these things are still there. We can still create functions, which is modular programming or functional programming. And on top of all of that, we can also have inheritance, etc., which makes it object-oriented programming. So if a language is an OOP language, it means that it can support everything before it plus more, right? It does not mean that these paradigms replace each other. In fact, they just add on to existing paradigms and build on them. That's how it works. Okay. So this was a quick tour of the history of programming and how things have evolved over time. I hope it makes sense, right? I hope these terms are clear. So abstraction, polymorphism, inheritance, and encapsulation, they are really important. We'll be reusing them over and over again over the next couple of sessions. That's the language that we'll speak. Class, object, again, these are going to be the terms that we'll see very common in the next couple of sessions as well, right? So that's a quick look at OOP. And that's what the next couple of sessions are going to be about. We'll start with Django next. And Django is basically a framework that Python provides for us to create our backend apps or APIs, backend APIs. So again, I will show you how to install it. I will show you how to set it up, create a new project, and all of that in the next one. Now I'm open for questions. So if you have any doubts or questions, please put them in the chat. I have both chats open. So YouTube Live is also open and Zoom chat is also open. You can put your questions in the chat and I'll quickly try to answer them one by one. And in the meanwhile, I'm also quickly just asking the team to share the attendance link in the chat. Okay. So that they will also send it. Okay. But yes, so if you have any doubts regarding any of the sessions so far, please put them in the chat. Okay. Today's topic is going to be object-oriented programming. Okay, so OOP, basically, that's the topic for today. You can mention that. Okay, yes. So yes, functions in Python OOP, you can mention OOP as well. That will also be fine, no problem. And the link will be shared in 2 minutes. I've already informed the team for that. We've begun the concepts, right? So whoever this devil underscore 666, we have already begun the concept discussion for OOP. So from next session onwards, we'll write the code for it as well. So that will start from the next one. Why we use Lambda? So Tejaswini, Lambda functions allow us to make anonymous functions. We don't have to assign a variable to it. right? If we have a normal function, we always have to say define function name, etc., etc. But in functions like map, filter, reduce, for example, we just want a quick, immediate function within the code. We don't want to make an external function and then reuse it. So in those places where we want a temporary function, a single line function without a name, we can use Lambda functions over there. Okay. So, Akmal, Amir, again, I think I told this to you yesterday also. Please go to the GitHub repository. There is recording links. There are recording links for all previous sessions over there. So you can please try to watch them. There is no separate link as such for practice and all. All of those are happening on the LMS. Okay. So all your assignments and all of that will be sent to you on email, and you have to make it on the LMS. Okay. I have given you the GitHub link again, so you can go ahead and check it out. I have uploaded the code for all previous sessions along with all the recording links over there. Okay. Now coming to the next couple of questions. So the next question is regarding assignments. So assignment submission, as far as I know, is till the end of the internship, like till before the project. So you can submit them later, but again, try to submit them within the week so that by the time you get the next assignment, the previous one is already done. Okay. So that way you don't have a backlog, because each assignment will take at least a couple of, like, at least an hour or so to create. So you will then have 4 or 5 hours of work pending. So it is better that you, quickly try to finish the assignments off as and when you get them. You will get another assessment tomorrow. So every week we are sending you one. Okay. Every week we are sending you one assessment. So yes, this week's assessment will be sent to you tomorrow. Right. Regarding the sessions, so this is the halfway mark. We have a total of 15 sessions and we are done with 8. So today was the 8th session. So we are 50% done. We have about 7 more sessions to go, out of which 3 sessions will be project based. So we have 4 sessions where we discuss concepts, and then in the last 3 sessions, we'll be making the project. So that's the setup. Okay. The employability tests are necessary, yes, for 2 reasons. Number one, for you, so that you get a better understanding of how things work while you apply for companies, and for us, so that we can match you better with the right companies. Right? So it's important to understand where you fit in so that we can match you with the right companies. And also, again, they are important for you so that you understand how things work as well. Okay. So yes, that's the answer to that. Hopefully it works. So again, for all LMS related issues, you will have to reach out to the team. Okay, because I don't have access to the LMS myself and I can't give you access either. So please make sure that you reach out to the team either on Telegram or on the support email. You have a WhatsApp number as well. So all of those details were shared earlier itself. And done. Yes. So I have requested the team to give the attendance link. They will put it in just a minute. So just wait for a minute and that should be sent. Okay. It's on the way. It will come soon. But yes, if there are any questions, do let me know. And yes. So assessments do carry grades, right? So for everybody who is wondering, is daily test necessary? Are assignments necessary? Yes, assignments are necessary because they have some 20% in your final grade. So that is based on your submission. So it's important. Okay. And then we have yes, so we will repeat these concepts like the OOPS concept that I shared with you today. Today was just an intro thing. When we write the code, okay, I will give you more information on them and I'll give you more examples as well so that you understand better. But yes, so that's something for the next session. All right, and there are no questions in the YouTube live as such. No, assignments must contain code files. So HTML file, CSS file, JavaScript file, or Python file, whatever the assignment is, you must submit code files. We are not accepting Word files. Okay, I want the code that you have written. So that's what we discuss. Python does support you can't write front-end code in Python, but you can respond with an HTML file created with Python. So there is a workaround. We'll talk about it later. But yes, so we'll discuss that as well. Okay. Yes, you have to submit assignments in TapTap only, which is our LMS. Regarding the project, the instructions will be shared with you later. So once we start the project, when we start working on the project, I'll talk more about that later on. Tejaswini, paradigm simply means a pattern or a structure. So an approach. So when we say conditional programming, it is basically writing code such that we can decide whether or not to run it based on some condition. So that's conditional programming. It's a particular approach to programming, which is a paradigm. So in general, paradigm means an approach, a pattern, an approach. Basically, that's what it basically means. Mrudula, HTML, CSS, and JavaScript. These three things come under front end. So three technologies: HTML, CSS, and JavaScript front end. And for backend, we are going to use Python. That's our backend. Okay. And done. So I've answered all the questions from the chat. Please wait for another minute or so. I'm not sure what's taking so long, but I've already asked that the attendance link is sent. So as soon as you get it, make sure you fill the feedback form before you leave, because attendance is important. It's being tracked. I hope you know that. So please wait for a few minutes. As soon as the link shows up, you can fill it in. Right? And I can't create a personal group like that because we have so many people. There are some 2,500 people enrolled in this one. Okay. So there are a lot of people enrolled. So we'll have to basically stick to the Telegram group that we have. And if you have any doubts or questions, you can always, reach out here in the session. I am keeping the last 15-20 minutes every day just for doubts or questions. So you can get them cleared right here. Okay, yes, I have to upload that on GitHub. Thank you for reminding. So somebody sent me a reminder to upload the code on GitHub, which is very important. So let me just do that quickly. The attendance link is going to be active only when 15 minutes are left. So we still have some 5-7 minutes for that. So in the meanwhile, I'll quickly update the GitHub repository. So this is session 8. So the file is going to be session_8.py. Just like in the previous one, it was session_7. So I am making another file, session_8. Okay. And okay, so I've uploaded the code file. If somebody can quickly check and let me know if it is visible, that would be great. I'm putting the GitHub link again in the chat. Okay, so I've pasted the repository link. If somebody can quickly check and tell me whether you are able to access the session 8 file, that would be great. And okay, perfect. So I believe, so there is somebody who's asking, can you write steps on how to write assignment? I believe that a video was already shared earlier with you. You can find it on your email, or I'm sure it's on Telegram as well somewhere, where the entire LMS overview was given. So there, the steps were clearly mentioned, for you to submit the assignment and all. Basically, you will get an email with the assignment link. You log into the LMS, it opens up like a hackathon style thing with a timer. So you start it, the timer will begin, and then you have to upload the files and then submit. So by the time you end it, when you end it, you have to upload all the code files. So make sure that if you're using HTML, CSS, JavaScript, please upload those files. And you can also make a zip. So you can put it all together in a zip file and also update it over there. Okay. So that's how you can submit your assignment. I am sure there are emails going out. I will still check with the team. regarding um, the assessment emails. I'll still follow up once, but as far as I know, because I am receiving those communications as well. So email is definitely going out because I designed the assignment questions myself. So I know exactly which questions are there and I am getting those alerts. So yeah, the emails are going out, but still, I'll still ask the team to check just in case. Okay, I'm just also taking a quick minute to update the session links as well so that the repository is up to date and you have access to everything in one place. All right, so yes, this is done. So if you just check the repository, you can see that I have uploaded all the session code all the way till today's session. And the previous recordings are also available till the previous session. So once this session gets over, I will add that recording as well. But yes, I have added everything till today. Okay, so you should have everything over here. And again, as per the schedule, the next session is going to be tomorrow. That's our schedule. Again, if there are any changes in that, you will be informed about it. Okay. But as of now, the next session is tomorrow, 5 to 7, as planned. Okay. But yes, if there are any changes to it, you will be informed accordingly. And the attendance link will be sent in 2 minutes at 45. So apparently it only becomes active 15 minutes before the end of the session. So we can't access it before that. So we still have about 2 minutes to go. And then the attendance link will be active. So then it will be shared with you. Okay, just wait for 2 more minutes and you will have it. Uh, I will try to get the links, Niharika. Okay, I will try to talk to the team. If I get assessment links, I'll update them in the repository directly so that all the links are in one place. Let me see if I can get access to those and I'll update it for you. So if I do get it, I will update it. Okay. Yes. So like I said, in the next session, we are going to continue a discussion on OOP by taking a look at the code. Today, we haven't written any code as such in OOP. We have just seen function code. We have not written OOP code. So we'll be doing that. And then we'll be moving to Django. So I'll give you a quick example of class object, etc. And then we'll move to Django in the next one. So that's the main setup. In Django, things are a little more complicated, right? Which means the structure is a little bit different. So we need to spend some time to understand that structure very carefully. So that's coming in the next one. We'll take a look at all of those steps. There are so many different files. We have to understand what each file does. So Django follows a particular architecture style called MVC architecture. That's model view controller. Again, I'll tell you more about it in the next one, right? So today's topic is functions and OOP in Python. You can also just mention OOP in Python. That should be fine. But functions and OOP in Python is the topic. And we are just giving one assignment per week. I don't think we want to reduce that. One assignment a week is nothing. Okay, we have 3 sessions. Earlier, we planned we'll give you one assessment per session. So imagine that would have been 15 in total. Now you only have 5. Right? So it's already reduced. We can't reduce further. Okay. No, Madhu, we don't have a class daily. It's actually thrice a week. But because of some emergency, I was not able to take one class the previous week. So only 2 classes happened. So to make up the schedule, we have classes today. Like today's class was a making up for the previous cancelled class thing. And then regular class timings are Monday, Wednesday, Friday, 5 to 7. That's the regular timings. We are using card total to store the result. Okay, it's just a variable. They just we need to store the value. And unlike the other values, which is a list, since reduce only gives us an integer, we don't want to store it in a list because it's not a list, it's a single value. So that's why we are using cart total for it. Okay, and done. So hopefully the link should come in any minute now because it's time. So the team said that they can only send it at 45. Otherwise, it shows that time up alert that we were getting yesterday. So I think that it should be sent anytime now. There you go. The link is now in the chat. Please fill it in properly. Yeah, please make sure you fill it in properly. And yeah, that's basically it for this one. Thank you so much guys for attending. Let's meet again in the next one and continue from there. So have a great day. See you in the next one. Bye-bye. Please make sure you fill your attendance sheet. It's really important. So fill the feedback that will be considered as your attendance. Okay. So the link has been shared in the chat. Please fill that in. And yeah, that's it for this one. See you in the next one. Bye-bye.